Here's a solution to number 36 from the homework, and I'll do some others in another video. But real quick, y equals 1 plus cosine of the quantity 3x plus pi over 2. So let's try and do this quickly. We'll get some axes set up. Label your axes always. Here it's x and y. Ooh, that's kind of tilted a little bit. Okay, there we go. So, but what we really need to do is get some data out of this. So let's see. Vertical shift. A lot of people miss that. Remember that 1 plus is going to be a shift of 1 up. So the center line is y equals 1. The amplitude, that's just the absolute value of whatever's in front of the cosine. So that's absolute value of a equals 1. I don't know why I took it out of math mode. Okay. And so that means we know the max and the min. Max is going to be y equals 2. And the min is going to be y equals 0. So we can put in some dotted lines now. And we've got an idea of the vertical scale we want. That's 1, that's 2. That's going to be as big as it ever gets. It's going to rest right on top of the axis, and here's going to be the center line. Okay. Now, let's look for the period. Period is 2 pi over b, and so that's going to be 2 pi over 3. And so the quarter period, so that's going to be 1/4 p is going to be pi over 6. Okay. And so that gives us an idea of our horizontal scale. Or, well, let's get the anchor point first before we start decorating the horizontal scale. Anchor point. So the x-coordinate of that is called the phase shift. I like to talk about the whole anchor point, which is actually a point to plot, but the phase shift is the x-coordinate of that. And the way we get that is 3x plus pi over 2. We set everything inside the cosine to be 0. We figure out what the magic x is. And we get x. When we solve that, we get x equals minus pi over 6. I'm doing a little fast on the arithmetic, but you can check me. Okay, so now we have a good idea of what's going on. Minus pi over 6 here for our phase shift, pi over 6 for our quarter period. So we're going to want to mark this out in pi over 6s. Pi over 6, pi over 3, pi over 2, 2 pi over 3, minus pi over 6. And please make these regular. I might give you graph paper on a test, but if you don't have graph paper, try to make them reasonably regular. Okay, so that's some pi over 6s. And maybe one more. 5 pi over 6. Okay. And so those are the points we're going to need to plot. And we're basically almost ready. The actual anchor point is going to be, there's the x-coordinate. And then we just need to figure out the y-coordinate. So we can either just plug that in. If you plug it in, you get 0 into here, of course. That's the point of being the anchor point. So 1 plus cosine of 0 is 1 plus 1 is 2. Or you can just remember that a positive cosine starts on the high side. And we already know where the high side is. We know it's that line y equals 2. So it starts high here. And if it starts high, then the next step is going to go to the middle. Remember, the quarter periods are just pi over 6. Here we're lucky because the phase shift was the same amount as the quarter period. This guy was just the same except for a negative as this guy. Sometimes if these guys are related in an unpleasant way, you might need to take like a common denominator, and that's where we got things like pi over 12 and things like coming out in some other examples. Here it doesn't happen that way. And so here's our graph. We just do the max min points, the center line points, and we connect them together. And that's 2 full periods, and that's what I would usually want. Okay, so notice what we've got. We've got a careful scale on each axis. We got axis labels. They're usually going to be x and y for these graphs, but I often use theta for here, or t is very, very important. So be careful not to just blindly put x and y. And we've got our landmark points, or our quarter period points, carefully plotted. And then the rest is sketched in between. That's what I require for these guys.